Hi guys, so this is the second part of our lecture in section 2.2, polynomials and their operations. So last time we were able to define what a polynomial is. So in here, let us just recall that a polynomial in the variable x, this is an algebraic expression of the form a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus and so on and so forth, plus a sub 1x plus a sub 0, where these a's here, a n minus 1 until a1 until a sub 0, these are real numbers. So they are constants. And they are called the coefficients of the polynomials. And in here, your n or the n here is greater than or equal to 0 and must be an integer. Okay? And if this guy here, a sub n, is not equal to 0, then we call this term here, a sub n x to the n, the leading term. And a sub n is called the leading coefficient. And furthermore, the n here is called the degree of the polynomials or the polynomial. So this is the definition. And then we did some work and we ended last time at this particular example. So now, as you can see in these examples, I use the variable x, okay? Of course, you can use other variables. So for example, we use y, then this is a polynomial um, in terms of the variable y, or you can use z. So this is a polynomial in the variable z. Okay. Now, the following here are not polynomials. For example, you have the 2 over x plus x. You can rewrite this as 2x raised to negative 1 plus x. And because the variable x here has exponents negative 1, this means that um, this guy here is not a polynomial. Remember that the um, exponent of the variables in the polynomial must be greater than or equal to 0 and an integer. So this guy here is negative. So this is not a polynomial. Also, if you have a quotient of two polynomials where the denominator has degree greater than 0, then this expression is not a polynomial. Okay? Now, there are still polynomials composed of a quotient of two polynomials. We require the denominator to have degree equal to 0. So, meaning, for example, if you have x plus 1 divided by 5, okay, this is still a quotient of two polynomials, but the denominator here is constant. Okay? You can rewrite this as 1 over 5x plus 1 over 5. And therefore, this is a polynomial. Okay? So again, if you have two quotients of two polynomials and the degree of the denominator that's greater than 0, then you don't have a polynomial. Okay? Now, one of the goals of this lecture is to define and to know uh, operations on polynomials. Okay? So just like in the set of real numbers, we have addition, subtraction, multiplication, and division. And earlier we discussed adding and subtracting common or adding and subtracting monomials. So we can also do that in the polynomials. Okay? So polynomials are added or subtracted by combining like terms. So this means you look at each monomial, okay? You find the like terms and then you combine them. Okay? So for example, let's have the sum of these two polynomials here, x cubed minus 3x squared plus 5x minus 2, and 5x to the 4 minus 2x cubed minus x plus 1. And then later we do this subtraction here. We have x cubed minus 2x squared plus 4x minus 5 minus quantity 5x cubed minus 2x squared minus x plus 1. So let's start with our first problem here. So in here, we want to add x cubed minus 3x squared plus 5x minus 2 plus you have 5x to the 4 minus 2x cubed minus x plus 1. So notice that they are grouped using the parentheses. Okay. If you are adding these two polynomials, these parentheses, you can just drop them. Okay. And the signs inside the grouping here or here, they will not be um, affected by the dropping of the grouping symbols. Okay. So if you have the addition, okay, meaning if we drop them, it's just x cubed minus 3x squared plus 5x minus 2. Then you have plus 5x to the 4 minus 2x cubed minus x plus 1. So by the way, I am doing this solution and I'll label it as solution 1. Later, I will show another solution where we don't do this, but we do it in another way. So I call this the horizontal method because I have written them horizontally. And later I will show the vertical method. Okay? So if we add polynomial to polynomials, okay, or we subtract them, we combine like terms. So in here, you look at the like terms. So for example, we have an x cubed here, and on the other polynomial, we have also the x cubed term. So for example, this guy here, this is like terms with this guy here, or like term with this guy here. So we can combine them, okay? So we have x cubed minus 2x cubed. That will be negative x cubed. And then we look at this negative 3x squared. So notice that there are no other x squared term here. So in that case, we'll just have to copy this. So minus 3x squared. And then in here, you have 5x. And if you observe clearly, you have here minus x. So they are like terms. So I'll just label them like this and this guy here. So notice that I am putting some marks below the term, telling me that these terms here are like terms. So underline and underline for the cube term. And here we have zigzag or whatever, this guy here zigzag. So I'm saying that they are like terms. So anyway, 5x minus x, that gives me plus 4x. And then I have the constant part here, minus 2. And then there's also a constant part on the other side. So we have, say, I'll just put caret or wedge on top of that constant. And also this guy, because this is the other constant. So minus 2 plus 1, that's minus 1. And then in here, I have 5x to the 4, and there are no other 5x to the 4. So I'll just copy that. So plus 5x to the 4. And all terms now were considered. Then lastly, all we need to do now is to rewrite this in standard form, meaning we rewrite this such that we start with the variable having the highest exponent. So we start with 5x to the 4. And then we get the cube part. So minus x cubed. And then the squared part, we have minus 3x squared. And then the x part, we have 4x. And then the constant, minus 1. So this is the sum of these two polynomials. Okay? Now, as I have said, I'll do another solution where this time I'll be doing this vertically. So listen very carefully. So this is solution 2. When doing or when adding or subtracting polynomials with another polynomial, you have to make sure that uh, like terms are on the same column when you write that. When you write polynomial on the first line and then the next polynomial on the second line. Okay? And also, be sure to um, provide space for those missing powers of the variable. Okay? So let us look at this. You have x cubed minus 3x squared plus 5x minus 2. All the powers of x starting from 3 down to 0, they are all present. So we don't have to skip some terms. So we write this on our first line. We have x cubed minus 3x squared plus 5x minus 2. And then the other polynomial, we write them or we write the terms on the second line. Now notice, we have here 5x to the 4. And in the first polynomial, there is no 5x to the 4. The highest degree that we see in the first polynomial is x cubed. So the x to the 4 term, it will be somewhere to the left of x cubed. Therefore, what I'm going to do is to write 5x to the 4 on the left of the x cubed term. So in here, I will write the 5x to the 4 on this part. And then I have the minus 2x cubed. I will write this in the same column of the term x cubed of the first polynomial. So this is your x cubed. I will write minus 2x cubed on the same column as this. And then there's no squared part. So I'll skip that. The next term here, it's the minus x. I will write this minus x on the same column as this 5x in here. So I will have minus x in here. And of course, the constant, it will be aligned with the constant 2 of the first polynomial. So this guy here is plus 1. So technically, you group this and then there's a plus in here because you are adding. But if you remember, I mentioned in the first solution, okay, since this is a plus, you can drop the grouping and no harm will be done. Okay? So if we add these two polynomials, all we need to do is to add the coefficients of the same powers of x. In here, there is no x to the 4 in here, so we'll just drop this. This is just 5x to the 4. And then in here, we have x cubed minus 2x cubed. We will get minus x cubed. Here we have minus 3x squared. There's no squared term in here, so we can just drop that, or we can just bring this down, this 3x squared. And then we have 5x minus x. We'll get plus 4x. And in here we have minus 2 plus 1. We have minus 1. So this is the same polynomial that we obtained in the previous solution. Okay? So this is addition. Now, let us consider the other one. Oh, by the way, this is duplicate, so I'll just um, skip this. So in here, um, we want to find the difference of this x cubed minus 2x squared plus 4x minus 5 minus 5x cubed minus 2x squared minus x plus 1. Now, we have the grouping parentheses in here. Unlike in the addition, we cannot just drop the parentheses. We cannot just remove it. Okay? Especially for this part here. Okay? Why? Because if you just removed it, um, this subtraction will have an effect only on the 5x cubed. If you just remove the parentheses in here. However, in actuality, this minus actually has an effect on the whole polynomial. So if you want to drop this grouping in here, you need to distribute this minus sign properly. So if you distribute this, you change the signs of those inside the grouping. Okay? So what I'm saying is, let's start with this. There is no negative sign in here. So for this polynomial, we'll just drop the parentheses. So we have x cubed minus 2x squared plus 4x minus 5. On the other hand, if we want to drop these parentheses, you have to distribute this negative sign properly. So in here, 5x cubed, there is no sign, so it becomes minus. Well, the sign here, it's actually positive, so minus times, or negative times positive, it will give us negative. So in here, we will have minus 5x cubed. For this is negative. So if we distribute this negative outside this parentheses, uh, this will change the sign of this. So this becomes plus 2x squared. Similarly for this is minus. If we distribute this negative, this becomes plus x. And then finally, you have your minus. You distribute it here. This is plus. This now becomes minus 1. And now we can start doing the addition. And this is, or subtraction, this is horizontally written. So we can just continue from here. We have the x cubed here, and there's an x cubed there. So underline, underline. So if we combine them, x cubed minus 5x cubed, that's minus 4x cubed. We have here minus 2x squared, and there's a plus 2x squared here. So they will just cancel each other. Okay? So this guy here will cancel this guy here. And then we have 4x and then plus x. So this is your plus x, this is your 4x. The same symbol used, meaning they are like terms. So we have here, so 4x plus x, that's plus 5x. And then finally, for the constant part, I'll use this zigzag and then this guy here. So we have minus 5, minus 1, and we have minus 6. So this is the final answer. Okay? Now, very common mistake. Students just drop this. And definitely, you will get a different answer. And that's the incorrect answer. Okay? Most probably. Okay? Actually, most probably in a sense that it's 99.9% incorrect. So don't just drop it. Be sure to distribute the negative sign properly. Okay. Now, let's go to the next operation, multiplying polynomials. So one way to multiply polynomials is by the distributive property. Okay? So what is the distributive property? If we recall, distributive property, you have A times B plus C. You distribute the A, okay? This is AB plus AC. That's one way to do the multiplication. So this is the left distributive property. And then we also have this A plus B times C. You distribute the C. We have AC plus BC. So this is now the right distributive property. But let's just call them distributive properties. Okay? So find the product of 2x minus 3 times x squared plus x plus 5. And then the other one, we have x plus 1 times 3x plus 5. So let's start from here. Again, for these two examples, we will apply distributive property or properties. So we start with 2x minus 3 times x squared plus x plus 5. So what we're going to do is to get this factor here and distribute it all throughout the terms of the other factor. Okay, so this is basically your left distributive property. From the left, we distribute it to all the terms of the right factor. So in here, we will have 2x minus 3 times x squared plus we have 2x minus 3 times x plus 2x minus 3, okay, 2x minus 3 times 5, okay? And then on the next step, what we're going to do now is to distribute this term here over the sum or over the difference. We also distribute this over the difference here and this guy here over this difference. So I'll write the solution or I'll write the steps here completely. So what we actually have will be, or what we'll actually get uh, are the following. So you have 2x times x squared minus 3 times x squared. So what I did, so this term here, I distributed it on each of the addend in this parentheses. And similarly, I will do that here. I'll distribute the x to each of the guys there, and also this to each of the guys here. So for this one, it's this first expression here. And then plus we have now 2x times x minus 3x. And then lastly, you have 2x times 5, okay, minus 3 times 5. And then from here, we just apply laws of exponents. So 2 is constant, and you have x times x squared. So power 1 plus power 2 for the variable x in here. So you'll get power 3. Okay? Also in here, you have x raised to power 1 times x raised to power 1. So you add power 1 plus power 1, you'll get power 2. So let's just do that and skip some details. But I expect that you know what to do at this point of our course. So this is 2x cubed minus 3x squared. And then for this, we have plus 2x squared, okay, minus 3x now. And then in here, you just have 2x times 5. So you just multiply the constants and coefficients. So you have here 10x. And then here, you just have 3 times 5. So you have minus 15. And then as you can see, there are still like terms here. You can combine these guys here and also these guys. They are like terms. So if we do that, we will have 2x cubed and then minus 3x squared plus 2x squared. That's minus x squared. And then in here, we have minus 3x plus 10x. So that's plus 7x. And then finally, we have minus 15. So this is the final product. Okay. Now what we did in here, we start with the left factor, distribute it to the right. Okay. And then the next step, we would have, or we had right factor distributed to the left. Okay. But you can reverse it in a sense that you start with the right factor, you distribute it to the left, and then on this part, on this step here, what you will do next will be the left factor, you distribute it to the right. So you can do that. Okay. And well, if you do that, of course, you will get the same final answer. For our next example, we will do that the second method. So I start with the right factor, distribute it to the left factor. So we have x plus 1 times 3x plus 5. So this guy here, we distribute it to each of the addends of the other side. So if we do that, we will have, so this is equal to x times 3x plus 5 plus 1 times 3x plus 5. So we started with the right factor, distribute it to the terms in the left factor. And then for this step, we now distribute the one on the left factor, okay, over those terms in the right factor. Of course, you do that also to this guy, but this is just 1. So all we need to do is to copy this 3x plus 5 and then remove the parentheses. So I'll do this again completely. I have x times 3x plus you have x times 5. I'll just write it as 5x. And then plus we have 3x and then plus 5. And then for this, we'll just multiply x power 1 times x power 1 here. So we'll get x power 2. But this constant 3, so you'll just write it on the left side. So you have 3x squared. For this, you have 5x, and you also have 3x in here. So let's just add because they are right, like terms. So plus 8x. And then finally, you have the plus 5. So this is the final product of this expression. Okay. So again, what we did here, our method was to do the distributive properties or to apply the distributive properties. Of course, there will be other methods on how to do the multiplication, and we will learn it in a few seconds. Okay. Now, we'll have another method of multiplying polynomials, but for this case, we will only have um, binomial times binomial. Okay, so for example, we have the binomial ax plus b. We multiply it to the binomial cx plus d. So this method is called the FOIL method. Okay, so FOIL, F means you have the first, O means you have the outer, I means you have the inner, and then L means you have the last. So what do these guys mean? So for the outer, or for the first, it means you need the first terms of each factor. So here you have the first term ax, here you have the first term cx. So that's the one that you multiply first. That's why you have here ax times cx. Okay? The outer, so if you look at this, if you write them explicitly, you have ax plus b, cx plus d, you will see the outer terms. This one is the leftmost term, this one is the rightmost term. So they are the outer terms. So you see that in here, you multiplied ax and d. And of course, you have the inner. So again, writing the product this way, you will see the inner terms, the two terms that is inside this whole expression. So they are this b and then this cx. So you see this b times cx. And the last here, it means that you have the last terms. So for this term here, for this factor here, you have ax plus b, you have the last term b. And then for the factor cx plus d, you have the last term d. So you have this b um, times d. So once you have this FOIL method, you can now combine them and simplify them, and you should end up with this guy here. Okay, so this FOIL is a standard mnemonics for this way of multiplication. So first, outer, inner, last. Okay, so these are the examples that we'll be doing in this particular method. Okay, so all of them are binomial times binomial. So let us start. So we want to find the product x plus 1 times 3x plus 5. Okay. So in here, you have, let me just rewrite that again, x plus 1 times 3x plus 5. So for the FOIL method, we have here the first. This is your first. So let me just write it here. First. So this means we multiply x and 3x. Okay. And then we have the outer. So this guy here, we have the outer. So plus x times 5. And then plus the inner. We got this. So this is your inner. 1 times 3x. 1 times 3x. Then plus, we have the last. So this guy here multiplied to that guy. Okay? So we have 1 times 5. And then you just need to simplify this. We have 3x squared plus, here you have 5x plus 3x, that's 8x. And then 1 times 5, that's just 5. So this is the final answer for this product. Okay? So when you do this during exams or quizzes or homework, you can actually skip this part. You can go directly to this if you've been doing this all the time. Okay? So you can skip this line and go directly to this. But if you're not used to doing this, you can just still write these terms here, so you won't get confused. So this is our first example for the FOIL method. Let's look at the second example here. So we have x minus 6, 2x minus 3. So again, we use FOIL method. Okay, so this is your first, this is the outer, this is the inner, and then we have the last. Okay, so for the first, we have, let's multiply them out. You have 2x times x, that is 2x squared. For the outer, you have x times negative 3, so minus 3x. For the inner, we have negative 6 times 2x. So we have negative 12x. And then for the last, we have negative 6 times negative 3, that's positive 18. So here, we can now simplify this. We have 2x. Then minus 3x minus 12x, that's minus 15x. And then we have plus 18. So this is the product. Okay? Okay. For our next example, we have this. We have x plus 3, x plus 3. So we are multiplying x plus 3 with itself. And again, we use FOIL method for this example. Later on, we will have another method in solving this type or this kind of products. Okay, so for now, let's just use the FOIL method. So this is f, that's the first, and then we have the outer, then the inner, and then we have the last. Okay, so for the first, we have x times x, we have x squared. For the outer, we have x times 3, so we have plus 3x. For the inner, we have 3 times x, so that's again 3x. And then for the last, we have 3 times 3, we will have 9. So if we simplify this, we have x squared plus 6x plus 9. And finally, for this last example, we have x minus 2, x plus 2. And again, we get the product of this using FOIL method. And just like the previous example, this is another special product. So we will learn another technique in multiplying this type of products. But for now, we apply FOIL method. So this is first, and then we have the outer, then the inner, and then the last. So here we have x times x, that's x squared, and then x times 2, that's plus 2x, then negative 2 times x, that's minus 2x, then negative 2 times positive 2, that's minus 4. So as you can see, 2x and minus 2x here will cancel. That's just equal to 0. And in here, we're only left with x squared minus 4. So this is the final answer. Okay. So that's our FOIL method. Let's look at now. So just like what I said, this guy here, this is actually a special product. So there's a shortcut in finding the product of this. Similarly, for this guy here, this is a special product. So there's another shortcut, finding the product of this type. So we call them special products. So let's start with the squares of binomials, or these are called the perfect squares. Okay. So in here, you have a binomial and you multiply it with itself. So you are squaring it. So in here, you have x plus a quantity squared. Okay. And then you also have x minus a quantity squared. So please remember this formula. So what's the formula for x plus a squared? So in here, we usually read this as follows. So square of the first term, so that's x squared, okay, plus twice the product of the terms. So twice, so 2 times x times a, or 2 times a times x. So that's your 2ax. And then plus square of the second term. So that's your a squared. So x plus a squared, it's equal to x squared plus 2ax plus a squared. Now, if you have minus instead, you put minus also in the middle. Okay? But it's the same concept. You have square of the first term, that's your x squared, uh, plus twice the product. Yeah, twice the product of the terms. But you have here 2 times x times negative a. Take note, this is minus, so negative a. That's why you have here minus 2ax. And then plus square of the second term. Take note, negative a times negative a, that's positive a squared. Negative times negative, it will give you positive. Okay? So again, x plus a squared, this is equal to x squared plus 2ax plus a squared. And you have here x minus a squared. This is x squared minus 2ax plus a squared. Okay? So this is the formula. This is the formula. Now, warning. Okay? Warning. Commonly, students do this. But I warn you, do not do this. Some students do this. X plus a or whatever x minus a squared. They put something like this. X squared plus a squared. And again, they are not equal. Okay? I already mentioned this during the lecture 2.1. Okay? But let me remind you again. You just can't distribute the power over the sum. But a lot of students are doing this. Please do not do this in my class. So remember this formula. Okay? Even if you have minus, they just put minus or they even put plus, but you cannot just distribute the exponent over the sum. So do not do this. Well, I mean, do not just distribute it because they are not equal. Okay? So let us consider our examples here. We want to find the product x plus 3 times x plus 3. This example was done before using the FOIL method. We will do it using our formula or using these formulas here. Okay? And then we will also multiply x minus 5 squared. Okay, so we will use this formula, the second one in here. So let's start with the first one. You have x plus 3 times x plus 3. Well, that's just x plus 3 squared. Okay, so using the formula, straightforward. Okay, we just have x squared. This is plus, so we put plus twice the product of the two terms. So 2 times 3 times x, and then plus the square of the second term. So if we simplify this, we'll just have x squared plus 6x plus 9. So this is the same answer that we got from the previous method. Okay? And just like before, you can skip this part, you can skip this part. So from here, you can just even write this guy here. Okay, and you won't lose any points. Next, we want to find the product x minus 5 squared. So we have minus here. We will use the second identity here. So we have x squared, so minus twice 5 times x plus 5 squared. And therefore, if we simplify this, we have x squared minus 10x plus 25. So this is the final answer. Okay? Questions so far? Next, special product here, difference of two squares. So in here, you have x plus a, you multiply it with x minus a. So you have a binomial, you multiply it with a almost similar binomial, except that the middle or the second term has another or has different signs. Okay? So you have here x plus a, the other one is x minus a. And you will end up with this guy, x squared minus a squared. That's why it's called difference of two squares. This is a square here, this is a square here, and you subtract. Okay? In order to prove this, you just need to use your FOIL method, you just need to use your distributive method, and you will see that the middle parts, they will just cancel each other. Okay? And you will end up with simply x squared minus a squared. So let us consider these examples. So x minus 2 times x plus 2, we did this in a previous example using the FOIL method, and you saw that we actually obtained um, the one in this form. Okay, this guy here. Okay, so we used FOIL method and we obtained something square minus square here. This is 2 squared. Your 4 is equal to 2 squared. Okay, so if we are going to um, directly apply this guy here, you'll just get the shortcut solution. And then we'll do the same for this guy here. So let's start first with this. So immediately, this is just square of the first term. So you have x squared minus square of the second term. So for this, I'll write 2 squared. Okay. But when you do this in an exam or quiz, you can simply write x squared minus 4. So you can just square this immediately. Okay. So therefore, this is a one-liner solution. X minus 2 times x plus 2 equals x squared minus 4. Okay? Next, we have here 2x plus 5 times 2x minus 5. So if you look at the formula here and even the formula in here, okay, you just have x as the first term. So x plus a, here you have x minus a, and then in here you have x minus x plus a times x minus a. So you just have the first term. And what happens is, what you do, you square the first term. On this particular example, instead of x, you have 2x. So 2x plus 5. But observe that the other term, you also have 2x as the first term. So 2x in here, 2x in here. And in here, you have minus 5 in this factor. Therefore, you can apply this formula. So how is this solved? Keep in mind that you have 2x as a single term. Therefore, the one that you are squaring is not just x, but the 2x. Okay? And then in here, you have plus 5 and then minus 5. So again, this guy here is applicable. You have now minus 5 squared. So if we simplify this, you have 2x squared, you apply loss of exponents, and then we calculate the square immediately, we will have 4x squared, and then here minus 25. So this is the final answer. And again, just like before, you can skip this part. You can immediately write 4x squared minus 25. Okay? Any questions? Now, let's go to another special product. We call this the cubes of binomials or the perfect cubes. So we had a formula for perfect squares. Now we look at perfect cubes. So here you have x plus a, you multiply it with x plus a, and again multiply it with the x plus a. That's why you have x plus a cube. Similarly, if you have the minus, we'll have a corresponding formula. So this formula here, you have here x cubed plus 3ax squared plus 3a squared x plus a cubed. Okay? And then for this guy here, you have, if you have minus x cubed minus 3ax squared plus 3a squared x plus a cube. Okay? Now, how can you remember this formula easily? So this is what uh, we do. So look at this. Try to observe. You have x cubed. The next term, it has x squared. The next term here, it has x. Then in here, you don't see an x. It's like you have your x raised to 0. Okay? So this guy, x plus a cube, what you can do is start with writing the variable x. Okay? The powers of the variable x, you write it in decreasing order starting with the cube because you are cubing it. So you have your x cubed, x squared, x, and then you can write x to the 0 if you want. But x to the 0, that's just 1. That's why you don't see it here. Okay? Then, you also look at the other term. You write powers of that other term, this time in increasing order. You look at this. There's no a. It's actually a to the 0. A to the 0 is 1. So you can start writing that a to the 0 there. It's just 1 anyway. And then in here, you have a to the 1. So you have a here. And then the next guy here, you have a squared. And then lastly, you have a cube. Okay? So again, you have this. X plus a, you want to cube it. You get the first term. You write the powers of that first term in decreasing order. So x cubed, x squared, x to the 0. You get the second term. You write the powers of that second term there in increasing order. So a to the 0, a to the 1, a squared, a cubed. Okay? And then lastly, how about these numbers here, the other coefficients? You have 3 here and 3 here. For now, I'll write it as this, 3 and 3. Later, I will teach you how you will get that. Okay? And then if it is a plus, okay, if it is a plus, you write everything plus. So you have your plus, plus, and then plus. So if you simplify this, well, you'll just have to remove a to the 0, that's just 1. Also, this x to the 0, that's just 1. You will have this formula. Similarly, for your x minus a cubed, the same method, you have x cubed, x squared, x, and then x to the 0. And then for the second term here, you have a to the 0, a to the 1, a to the power 2, and then a cube. And the number 3 here, or the coefficients, the other coefficients, you have here 3, and then 3. For the signs, you write the signs alternately, plus, minus, plus, minus. So this is plus, this guy here will be minus, this guy here will be plus, this guy here will be minus. Okay? But the question is, how do these plus and minus really appeared there? Take note that this minus here, it's actually attached to a. Of course, you have negative a to the 0, that's just positive 1. In here, negative a to the 1, that's negative a. In here, you have negative a squared. So negative times negative, it becomes positive. That's why you have plus here. and then negative a cube, okay? Negative a cube, negative times negative times negative, you get a negative number. That's why you have minus here, okay? So it's not really some hard method or technique, okay? It really came from the powers of a, or the powers of negative a. That's why this plus minus will appear. Okay? Questions so far? Now, what about these coefficients? The 3 here. Okay? What about the 3 here? Let me erase this part. Let me now show you what is called Pascal's triangle. So what is this Pascal's triangle? Okay? This is a method on a method in identifying, or a method to identify those coefficients. Okay? This also is called, or this is equivalent to getting the what do we call that? The binomial terms. Okay? But anyway, I'll show you what this Pascal's triangle is. You start with 1 at the top of the triangle, and then you go down here and down here. You have here 1 again and 1 here again. Okay? And then from here onwards, of course, you go down here and you go down here. You also go down here and you go down here. What you actually do is, when you have this common point, you add the numbers above them, or above this common point. So in here, you just go down, okay? But for this, you add these two numbers. So 1 plus 1, you will get 2. In here, you just go down. So this is just 1. Go down further, you have this. You also have this and this. And you also have this and this. Same method. This guy here, you go down. For this point, you add them. So 1 plus 2, that's your 3. For this point, you add these two guys. So that's again 3. And then this guy here, you have 1. Okay? You can even extend this. Okay? You can even extend this. So let me just move it here to have more space. Okay? If you go down further, of course, you will have something like this guy here, this guy here, and then this guy here. So same method. This guy, you go down, it's just 1. For this, you add these two guys, it's 4. For this, you have 6. For this guy here, you have 4 again. And then in here, you have 1 again. Okay? So this is Pascal's triangle. And what about this Pascal's triangle? You look at the rows here, okay? This guy here. These numbers that you see are coefficients of your binomial expansions. Okay? Coefficients of your binomial expansion. How is that used? For example, this guy here, the one in here, it's actually the coefficient of x plus or minus a to the 0. But what is x plus or minus a to the 0? That's just 1. That's why you have just 1 here. For the second row here, this is your x plus a to the 1. But what is x plus a to the 1? It's simply x plus a. So the coefficient of x, it's 1. The coefficient of a here, it's 1. What is this 1 to 1? This is your x plus a quantity squared. Do you remember the expansion of this? This x plus a quantity squared, if you expanded this, you will have x squared plus 2ax plus a squared. You see? 1, 2, 1. Okay? 1, 2, 1. And if you look at the x and the x here, it's x squared, it's x, and here x to the 0. And then the a to the 0, a to the 1, a squared. Same method as in the one I taught you just earlier. And then for the x cube, for this 1, 3, 3, 1, this is your x plus a cube. And as you can see, you have here 1, 3, 3, 1. Okay? And what do you expect for this? This line here can give you the formula for x plus a to the 4th power. And let's actually derive this x plus a to the 4th power using these coefficients here, so called the binomial coefficients, and then using the method that I showed you earlier. So you have here x plus a to the 4th power equals. So again, you look at the first term, you write the powers of that starting from the highest power, which is 4 in here, and then decreasing. So x to the 4, x cubed, x squared, x, and x to the 0. And then you get this second term. You write the powers of the second term in increasing order, starting with a to the 0. So this is a to the 1, a squared, a cubed, and then a to the 4th power. And then looking at the binomial coefficients here, 1, 4, 4, 1, 4, 6, 4, 1. So this is 1, okay? This is 4, this is 6, this is 4, this is 1. If plus, you just put everything plus. So here you have plus here, plus here, and then plus in here. And again, you can now remove your a to the 0 and x to the 0. They're just 1. And you have the formula for x plus a to the 4. If you got instead x minus a, so if you have minus instead, you write the signs in alternate manner. So this is plus, this is minus, this is again plus, this is minus, and the last one will be plus. Okay? So if you got minus, alternate in signs. So plus, minus, plus, minus, plus. Okay? And you can do this to all powers. X to the 5 or x plus a to the 5, you extend this again down there. You'll be able to write a formula. for your x plus a to the 5. And then you move further down and yeah, so that's how these coefficients can be obtained using Pascal's triangle. Or if you have taken or you will take statistics courses, you will also see this. The formula for the binomial coefficients. Okay? So this is similar to your combinations. If you have that. Anyway, so I'll not talk about that. But yeah, this is how we can get these formulas. But of course, for you, you'll just have to memorize this. But if you can't memorize it, at least you know how you can get it or how you can derive it. Okay. So much for this Pascal's triangle and binomial expansions. Let's look at some examples. So in here you have x plus 3 cubed, and in here you have x minus 5 cubed. So if we do this, let's start with x plus 3 cubed. So this guy here, this is equal to x cubed. Since this is a plus, everything is plus. So x cubed plus 3, that's because of this 3. And then a, your a equals 3. Then x squared plus 3, that's because again of this 3. And then 3 squared because of this. So this is your a. And then you have your x here. And then plus 3 cubed. So if we simplify this, we have x cubed plus 9x squared plus 27x plus 27. So this is the answer to that. Questions? For our next example here, we have x minus 5 cubed. So this time we have minus, so we have alternate in signs. So here you have x cubed and then minus 3 times 5x squared and then plus 3 times 5 squared x and then minus 5 cubed. So this guy here, it's equal to x cubed minus 15x squared plus 3 times 5 squared. 5 squared, that's 25 times 3, that's 75. So plus 75 squared minus 5 cubed, that's 5 times 5, 25 times 5, that's 125. So this is the final answer. Okay? Questions? So that's for the multiplication of polynomials. Let us now look at division of polynomials. In particular, we will only consider dividing a polynomial by a monomial. Okay? Now, recall if you have some number divided by another number, the one before, the one in on the left, we call it the dividend. And the one on the right here, you call it the divisor. Okay? So A divided by B, your A is called the dividend, your B is called the divisor. Okay? So if you do this, what you will get is the following. You will get a quotient, and then you will get another expression. The other expression, it's composed of what you call the remainder, and then you divide that remainder by the divisor. Okay? So this is dividend divided by divisor. This is equal to the quotient plus remainder over the divisor. Okay? Now, when dividing a polynomial by a monomial, what we actually do is to divide each term, okay, each term in the dividend by the divisor. Okay? The divisor is a monomial. So, meaning you can just separate each of the term in the dividend. Okay? And by the way, this dividend divided by divisor, okay, this can also be written as dividend here and then over divisor. Okay? So if you have this symbol here, it's the same as this fraction. Okay? So you can write this guy here in fraction form. And this also means division. Okay? So here you have x squared plus x plus 5. You divide it by 2x. Then the other guy here, we want to divide 3x cubed plus 4x squared plus x plus 7 by x squared. Okay? So let's do this. We want to divide x squared plus x plus 5 by 2x. So here we have x squared plus x plus 5. We want to divide this by 2x, but just like I remarked earlier, you can write this as x squared plus x plus 5 and then divided by 2x. And then when dividing a polynomial by a monomial, we said that we can separate these numerators here. In a sense that we can rewrite this as x squared over 2x plus x over 2x and then plus 5 over 2x. And then you can apply your laws of exponents in here, particularly in this part and on this part, or you can do your cancellation thing. You have power 2 here in the numerator, you have power 1 here in the denominator, so you can cancel one of the powers, particularly the power 1. Or if we applied laws of exponents, so the 2 on the denominator, I can separate it as 1/2. And then in here, just for the sake of recalling the laws of exponents, I'll do the laws of exponents in this guy and in this guy. So in here, you will have x squared minus 1 because this guy here, it's power 1. So if you bring it up, we now have minus 1. And then similarly, I'll separate this over 2 in the denominator. So you have here just 1/2. And then in here, you have x raised to 1 minus 1, and that will give you x to the 0. And then finally for this, there's nothing to do, so let's just copy it. So 5 over 2x. So if we simplify this, we will have 1/2 x plus 1/2 plus 5/2x. So this will be the final answer. Okay? Now, if you would ask in the exams or quiz or homework, you can skip this part. So from here, okay, from here, you can jump immediately to this, meaning you do all the cancellations immediately. Okay? Questions on this part? Let's have another example here. The second example for this operation. We want to divide. Let's write it immediately as 3x cubed plus 4x squared plus x plus 7. Divide this by x squared. And then we separate. We have 3x cubed over x squared plus 4x squared over x squared plus x over x squared plus 7 over x squared. So if we simplify this, we have 3x squared over x squared. You can cancel the x squared here and then you subtract 2 to this power. Okay? Or you can apply your laws of exponents. But you can write immediately 3x, that's x cubed over x squared, you'll be left with x. In here, totally your x squared will cancel each other here, so you'll just have 4. While on this, you can bring this x squared from the denominator to the numerator, but you will end up with a negative exponent. So instead of bringing up this x squared from the denominator to the numerator, what you can do is to bring down the x in the numerator to the denominator, so that when you simplify it, you will have 1 over x. And it's also the same as canceling. You cancel x to the 1, you subtract 1 from 2, and you will get 1. So that simplifying this, you will get 1 over x. And then finally, you have your 7 over x squared. So this is the final answer in here. Okay? Any questions? So as of this moment, we only divide polynomial by a monomial. Okay? Of course, you can divide polynomial by a binomial, or you can divide polynomial by another polynomial. Okay? But we will not discuss that in this course. But you may see them in some references that we are using. Okay? At least the ones that are listed in the course outline. But for this course, we'll just have polynomial by a monomial. Okay? So any questions? So we have polynomials from the previous um, class, and then we did this operations on polynomials: addition, subtraction, multiplication, and division. And we are only considering polynomials in one variable. Okay? But in general, we can do this in at least 2 variables. We may have 2, 3, or 4 variables and even more. Okay? So don't be surprised if you see 2 or 3 variables or 4 variables in this course, because they are also considered. For example, let us talk about polynomials in 2 variables. So a monomial in 2 variables, say you have x and y, okay? It has the form ax to the n, y to the m. So your variables x and y, they are multiplied to each other, and x and y has their own powers. They may have the same power or not, you know. And there are terms where you only see the x or the y, or of course the products of x and y and powers of that. So a here it's a constant, x and y are variables, n, m are non-negative integers. Okay, again, non-negative integers. The degree of the monomial, or the degree of a monomial, this is the sum of the powers of the variable. So the degree of this monomial, you just add n and m. As a whole, the degree will be n plus m. So for example, here you have 3xy cubed. Power of x here, it's 1. Power of y is 3. You add them, 1 plus 3. This will have degree 4. Similarly, you have here negative x squared y squared. Power of x is 2. Power of y is 2. You add 2 plus 2, you'll still get 4. And in here, you have minus 2x cubed y. Power of x is 3. Power of y it's 1. 3 plus 1, that's 4. So all of these monomials here have degree 4. Okay? Of course, just like before, a polynomial in 2 variables, it's just sum of monomials in 2 variables. Okay? And the degree of the polynomial in 2 variables, it's the highest degree of the among the monomials that you see in the polynomial with non-zero coefficients. So for example, in here, x cubed minus 2xy plus 5x squared, y squared minus y plus 1. So here, the degree of x is 3. So the degree of this monomial, it's just 3. Here you have minus 2xy. The degree of x is 1. The degree of y is 1. As a monomial, the degree of minus 2xy, it's 2. In here, you have 5x squared y squared. The degree of this monomial, it's 4. It's because 2 plus 2 here. Here, minus y, the degree is just 1. And of course, constant's degree is 0. So the highest degree that you have here is coming from this term. And the degree is equal to 4. So the degree of this polynomial here, it's 4. Even though you don't see actually the 4, this is 3, etc. You don't see actually the 4, but because if you have 2 variables, products of variables, you actually add the exponents of each variable. So this guy here gives you the degree of the polynomial. Okay? Questions? So just like I said, don't be surprised if you see 2, 3 variables in a single expression. Now, what I want to emphasize for this part here, well, one of those things that I need to emphasize on this lecture is what we call the substitution and evaluation. So a lot of times we will substitute because these are all variables, the x, the y, later the z, and etc. These are all variables, meaning they vary, meaning they can have actual values. Okay? So when we get some actual numbers, okay, and use that instead of the variables, what we are actually doing is substituting, okay, or evaluating the expression with the actual numbers. So substitution and evaluation, it's the replacement or substitution of the variables takes place each time the variable appears in the expression. Okay? So for example, here we have 3x squared minus 5x plus 26. We want to evaluate this for x equals -1. So what does this mean? We replace the x with this -1 so that we will have 3 times -1x minus 5 times -1 plus 26. So this is substitution, or this is evaluation. So if we simplify this, we will have -1 squared, that's just +1, so we have 3. -5 times -1, that's +5, so +5. And then here plus 26. So this is equal to 34. Okay? And then one last example for this lecture. We have 9x minus 5y plus 2xy. We want to evaluate this for x equals 2 and y equals 1. So meaning for every x that we see, we change that to 2. And for every y that we see here, we change that to 1. So in this, we will have 9 times 2 minus 5 times 1 plus 2 times 2 times 1. And therefore, we just have here 9 times 2, that's 18, minus 5 times 1, that's just 5, plus 2 times 2 times 1, you have 4, so that this is equal to 17. So this is the answer in this evaluation. Okay?